Hi, this is Dave. In this installment of Dr. Dave's Diversions, we're going to dive into another ancient version of Unix, and I'm going to show you a programming language that I'll argue is the least well-known Unix programming language there is. The language is called BS, or Basic/Snowball, and it was written by Dick Haight in the late 70s and available in System 3 in 1980. I'm going to tell you about how I solved the mystery of where BS came from. I was first introduced to BS when I stumbled across it, literally by listing the bin directory in the mid-90s. In 1996, I used BS to write a simple program that emitted the words to the song 99 Bottles of Beer, just like in my previous video when we looked at Ken Thompson's BASIC, and I did that. At the time, it was in my 20s, I was sort of moving towards the height of my programming capability, and just for fun, I would look for new languages that I could learn to enter them on that website, 99 Bottles of Beer. So I do an ls in the bin directory, and I find this command called BS that I had not heard of before. The man page says it's a version of BASIC, or a dialect of BASIC, that also integrates some features of Snowball. So from the man page, I learned enough about it to write the program, and I'll show you that program in the next chapter of the video. But first, I want to tell you about how I found its origins. In the UNIX System 3 man pages, prominently in the introduction to UNIX System 3, there's a section that says writing a program. In that section, the sentence reads, the four principal languages available under Unix are C, Fortran, BS, and assembly language. And it describes BS as a compiler interpreter in the spirit of BASIC. So I know a lot of the people that wrote Unix and that were working at AT&T at the time are still around, and someone must know where this BS command came from. And the first thing I decided to do was to write to Doug McElroy, who's on a faculty member at Dartmouth. And Doug writes back to me, sorry, I don't happen to know anything about BS, even though it was in System 3. And he referred me to Ted Delata, who was the gentleman that edited the documentation for that version of Unix. Unfortunately, I discovered that Ted had passed away. But Doug had said, given the frequency of contact between the programmer's workbench people like Ted Delata and research, he would have expected to have heard if there was a new language in PWB. The next thing I did is I wrote to Brian Kernighan. And Brian says, he writes back and says, I have no memory of this language, I fear, but he refers me to John Massey and Steve Johnson. And he says John Massey was a central part of PWB, or the Programmer's Workbench versions of Unix then, and Steve Johnson spent time on many versions of System 5. So then I write to Steve Johnson, and Steve Johnson writes back, sorry, I know nothing about it. But luckily, next we get to John Massey, and John Massey replies to me. He says, I'll look at the various manuals when I get home, but it's certainly not from the early PWD days. It's the sort of thing I would have promoted. So a little bit of time passes, and John writes to me and says, so the origin of BS is still a mystery. And he says, I'll contact Rod Kennedy. A little bit of time passes, and John Massey writes back to me and says, it turns out BS was Dick Haight. So now I've got the name of the author. So I tracked down to Dick Haight, and I had a nice exchange in emails with him. And Dick writes to me, I wrote BS at the time, Unix version 3 ? And all of the commands were being converted from assembler to C. So this is an aside by me. In the late 1970s, they're taking the version of Research Unix that was on the PDP and converting various components of it to C so that it can be portable to other platforms. And this sets them up for releasing commercial versions of Unix as well. So Dick continues, he says, so Thompson's BAS became my BS, sort of. I included Snowball's succeed-fail feature, the question mark operator for fail return. I also wrote find CPIO, EXPR, and POpen. So really interesting. I spent a little bit of time exchanging messages with Dick, and the next thing he says to me, he says, I asked him about, how did it happen? Was he directed to write this? How did it happen that the BS that you'll see is so different from the BASIC that was there before? And Dick writes, no one asked me to write BS. I'm just a compulsive programmer. I tried to get Dennis Ritchie to add something like the question mark / fail function to C, and he didn't. And that's probably part of why I wrote BS. So he had particular features of the Snowball language that he wanted available to him in Unix. So he added that in there. And then he says, I wasn't part of the Unix inner circle like Thompson, Ritchie, and McElroy. Neither were Massey and Delata. We were support. So sometimes I wrote programs just to irritate research into reacting. So we have different factions or different people in AT&T that influence the way that Unix works. And Dick wrote a number of important components to that. And I want to show you today one of the, as I said, one of the least known programming languages in Unix that's still available to this day in System 5 derived commercial Unixes like HPUX and AAX. I'll first show you how we're going to run the original BS that was available on System 3, and then I'll show you the language itself. Come back at the end if you want, and I'll tell you about some thoughts I had about what I've discovered about the language and where does it fit, in my humble opinion, in Unix history. So how are we going to run Dick Haight's BS, the basic snowball interpreter command? Well, we need to get a version of Unix that has this. There are very many versions of Unix, especially commercial Unix, that include BS. But the first version of Unix that it appears in is System 3. And from the Unix Heritage Society, we can get the tape distribution of System 3 for the PDP-11. And that's what we're going to do here. So I have the links to these instructions and to where you can get this dis.tape file in the description, but I'll show you step by step how to do it. All right, so once you've downloaded the dis.tape file, we're ready to create an install.ini file with this content. Then we're going to run PDP-11 on that install.ini file. So here we'll say no. Here we'll say yes. Say 0. We say ready, yes. Here we say yes. Here we say 0. Ready, we say yes. That's okay, return. This is the tape will not be around. Now we're ready to say, to boot. So we're going to say boot RP0. At this prompt we type 0. Don't type the equals, it types that for you. And we say UNIX HPTM to tell it which kernel to boot. And now we're in. It says UNIX 3.0.1, also known as UNIX System 3 in Roman numerals. And if we run the uname-a command, sure enough, it says we're on UNIX System 3. ls, this is the root directory. Now remember, we're just in single user mode, and there are a whole bunch of instructions at the link before if you want to build the whole system. We don't need to do that because we have the bs command. So we're ready to go, and it's in our path. So because I've not completed the installation here, I don't have the temp directory, so I'm going to use the lost and found directory as my temp directory, and I've put a number of BS source files in there already, and they are, and we'll use those to demonstrate the features of the BS programming language. So if you watched my previous video, the first thing I started off with showing how Ken Thompson's BASIC, the BAS command, can be used as an interactive calculator. And I used a couple contrived examples, one to calculate the number of inches per second that light travels, and the other one was a calculation for the amount of interest on a loan. Well, as it happens, there's a particular reason I picked those examples, because those examples are from the BS man page. Presumably those examples were written probably in the late 70s, almost to 1980, right before it was released, and they demonstrate that the BS command can be used like the BAS command that preceded it. So let's take a look at those. The first one we have is inches per nanosecond, and if I go into BS and type an equation like that, I get an answer. So it can be used as an interactive calculator, and that is exactly the same syntax that Ken Thompson's BASIC would accept to do the same thing. The other one we can look at, and it's a sequence of those four commands to be run interactively. And if we run those in BS, we see that works as well. And in both of these cases, these are examples of mathematical equations or operations that you could do in other BASICs as well. For instance, you could do it on the Commodore VIC-20 in 1980, as I show here. So it's basically showing that this is what people expected of BASIC at that time, or could expect of it. So what else do we have? Well, Like last time, we can use the 99 bottles of beer examples. And I've written 2 examples to demonstrate to you the BS programming language. So this version of 99 bottles is the one that I wrote in 1996 on I believe an HPUX machine with the BS command there. So when I discovered the language, I learned it enough so that I could write this example for the 99 bottles of beer website. So let's take a look at this example and see what are some of the unique features and interesting features of the BS programming language. Well, the first thing we see is a function definition. BS is the only language that I know of, and you tell me if you know of another, that defines its functions using fun and closes them using nuf. There are other examples like that in, for instance, the Bourne shell case in ESAC and do and OD in some languages, but I've never seen fun enough before. So then the function definition, it has a name and it has parameters or arguments to the function, and then it has a list of local variables. This is common from other languages. Then let's before we tackle what the rest of this function is doing, let's go down to the for loop and look at it here. So this for loop is defined using a variation of the syntax that we just used when we were doing that interest calculation. The syntax that Ken Thompson's BASIC used was for variable equals initial condition and final condition are the 2 values that it's going to count between. BS supports that for loop, but it also supports a more C-style for loop, which is what you see here, where the first expression initializes, it runs when the loop starts. The next one is the condition that's tested each time around. And the third expression is something that usually is an increment operation. It's something that you're going to do every time the loop around. Because of the particular way that the words to the song are, it happens to be more convenient to decrement the counter in the middle rather than do it in that third operation. So I do that in the middle of the block. And the for block is terminated with next, as is the while loop in BS. So what's the next curious thing we see? Let's take a look at this line. Put equals is the equivalent of a print statement for BS. Then we call the function sing, and we pass as this first argument the value n, that number, formatted in a specific way. Well, C programmers will recognize this instantly. This is a printf format here with the conversion specifier f saying a floating point number, and we're saying we don't want any zeros. We basically want to show it as a whole number. So minus 0.0 means the minimum and maximum numbers of digits before and after the decimal point, and the justification is specified by the minus. So that's just formatting the floating point number 99 as 99, for instance. And then the second argument to sing is the rest of the sentence. So what I've written here is the function sing that encapsulates the oft-repeated phrase in the song, where you keep saying n bottles of beer, n bottles of beer, n bottles of beer, and that's what that function's responsible for doing. And then so the first argument is simply the number n, and the second argument is the trailing portion of that sentence. So we're writing essentially here the most compact version that I could think of to write the 99 bottles of beer song in BS. And the function here then, the first thing we do is we come in and we say, we call the match function. So BS has regular expressions. It understands regular expressions, and I'm using it here just to demonstrate that it has regular expressions. This isn't the only way you could do this. Basically what I'm going to do is test the value of n to see if it's 1 or not. Well, you could do that with the equals operator. Is it equal to 1 or not? But here I decided to turn it into a string and match it against the string 1. And if it is 1, then we're making the word bottles singular or plural here. So it's choosing from an array sort of structure here in parentheses defined on the fly, where the 0th one is the S and the first one is the empty string. We choose which of those two S will be set to. This is very much like in C, the question mark colon operator, sort of a short circuit way of doing an if then else. And then what do we return from sing? Well, we return the thing that it's going to print, and that's going to be the phrase with the number n of bottles substituted in there, the letter S substituted here, or nothing if it's singular, and then the trailing part of the phrase or that part of the song here. So what am I doing? Well, what I'm doing is, because the format function has this weird restriction in BS, in C, the printf, you can say in the format in the format, you can specify a whole slew of things to be converted, and then you just pass a variable number of arguments. Well, in PS, the format function is more restricted than the one in C that it's built upon. You can only pass one at a time. So what I do is I call format 3 times. The first time it substitutes the number or the value n for %s here. The next time I call format, it expands %s to the s or the blank character here, and then the third time it calls format, it substitutes this %s with the end of the sentence, or the that's being sung at that point. And format each time returns a string that the next call to format uses. So I'm sort of, in a weird way, kind of almost, well, it's not recursive, but I'm calling it as I'm passing it to those functions. And I'm using a feature of the C printf, which is to protect a % by doubling it up. So that the % doesn't get treated as a conversion specifier the first time. I have to double it, so it doesn't get treated as a conversion specifier the second time. It has to be doubled twice. And then in the initial time, it doesn't need to be doubled at all because we just substitute it there. So that's some very weird ways of using the C printf. And then let's run that. And we see it prints the words of the song, as we'd expect. So what are we going to look at next? Well, one of the things that happened with that version of the program is, you can see I had to do this really weird thing with the format function in Dick Haight's BS. And I had to call it many times. I had to do this obscure thing where from another language, where I doubled up the % signs to get the formatting to work weird. That's presumably, that's less than ideal, and probably not the way that Dick wanted to be at the time either. So why didn't he make it like the cprintf function? Well, an interesting thing about BS is that it uses the same narg and arg functions that Ken Thompson's BASIC had for calling functions. You could ask the language how many arguments were passed to the function that I'm in, and you could address them and index them by the argument to the arg function. So how does that work in here? Well, let's take a look at that and see if we can't fix this situation where the format function only takes one argument at a time by introducing a new formatting function that takes a variable number of arguments. And that's a pretty advanced feature. The C language has it, and some other languages that aren't strongly typed may have it as well. But let's take a look at that. So the next version of 99 models, the for loop is essentially the same. The function call here is where we change it. Instead of calling format 3 times to format each one of those parameters individually, let's introduce a new function, the string printf function, or sprintf, and essentially make it work like it does in C. So how do we do that? So up here I introduce the function sprintf. The first argument it takes is the format of the style that C's printf or sprintf does. And then it takes up to 8 arguments, which are the numbers and strings that are going to be converted according to the format specified in the format specifier. And I found that I was able to write the sprintf function using primitives in the BS language. So I'll use a while next loop. I won't go into some of the details here. You can read the code. I'll put a link to it just to save time. Lastly, I've named these functions really weird names. Why did I call them GSPF? I called them that because these are global variables. These are not local variables of the function. And so I'm putting this GSPF for global sprintf prefix on the variable names to set them aside in the variable namespace so that other global variables won't collide with it. It's basically saying that this is a variable only used by sprintf. And you can say, Dave, why did you do something so primitive as to use global variables in this function? Why not local variables? Well, I did also try writing this function with local variables, where what I would have done is over here at the end of the line after arg8, I would have listed the local variables. two problems that BS introduces here. BS puts a limit on the total number, the combined number of parameters and local variables in a function. The man page says it's 10, only 10. And what I found, it seems to me that it also counts the function name as one of those. So you only have 9. So if I have 5 variables to implement what I want to do, which I do here, that leaves me only with 4 left for the parameters, one of which is the format itself. So that would only leave 3 possible arguments, and it would be sort of an emasculated version of printf. And I wanted it to do better than that. So I moved the variables to the global space so that I could use more of the 9 or 10 possible parameters as arguments to the function instead of local variables. The other thing I think I found is a bug in BS, that if you use local variables and you pass too few arguments to the function, because we're trying to use this variable argument count feature, it seems to mess up the stack. At least that's my initial impression, and I struggle with that a lot. And as soon as I converted to global variables, it worked. So I think there's just a bug in there having to do with this sort of not really documented feature that you can pass a variable number of arguments to a function in language, but this version works. So, so we've got it there. Let's run it. And we can see now this version emits the same words as before, but we've written it in a way that a typical programmer would probably prefer, where we were able to format it in this way that a Unix or a C programmer would recognize in a second. So that's my tour of the BS language. A couple other things. It has recursive functions. So I wrote, for instance, calculating the Fibonacci sequence. There's some fixed limits in the language. It sometimes gets an error that says you've recursed too deep in the stack, but pretty functional. So that's Dick Haight's BS programming language and command that's available in a plethora of Unix implementations. Basically, a lot of commercial Unixes that are derived from System 5, they have that. AIX to this day has it, HPX has it. Let me know if you have it on your version of Unix, and try out the programs that I wrote. Tell me if some of those bugs I discovered, for instance, one of the local variables, tell me if it's fixed. I'll put the version that uses local variables up as well. The thing that I really enjoyed about this project, I didn't mention, it was 2019 when I was corresponding with those different Unix luminaries who had forgotten or didn't know about the BS command. So it was my pleasure to rediscover that command and capture some of the history of it by talking to Dick himself via email and capturing some of his quotes. I'm happy to say Dick wrote to me. He said in 2019 at 86, I still program every day. He gave me a link, which I'll include in the description, to his blog about how he works on the Raspberry Pi. He says he works on Raspberry Pis, particle photons, writes in C++, only uses the C subset of it, PHP, Bash, and Python. So, well into his 80s, he's still doing this work, and I'm happy to have captured, one of his babies here. So what did I do with the information? Well, to capture it for posterity, I wrote the Wikipedia article about BS. So I refer you to there if you want to know more about it. And then I want to leave you with a couple of parting thoughts and tell me what you think. I propose that this language, it solved 2 problems. It replaced BAS, that was written in assembler by Ken Thompson, by accepting exactly the same interactive syntax so that people could use it like a calculator. But then for the programming aspect, Dick threw the basic part with line numbers and all that stuff out the window and started from scratch and wrote a pretty interesting program that I think is sort of one of the early kitchen sink sort of languages. And I don't mean that in a pejorative way, but I mean one that pulls things from different places and makes an assemblage that's better than all those individual parts. And I think that's what he was trying to do, and we'll let you and posterity be the judge of whether or not that happened or not. But I thought it was a pretty interesting language to work in, and really a testament to its value in that I was able to extend it to do something that it couldn't do. That's what I have for you today. I'm going to stop writing 99 bottles of beer programs in ancient Unix dialects for a little bit, but I'm going to open a real beer and enjoy that. Join me next time on Dr. Dave's Diversions.